Recently, I came across stored procedures at work. In this video, I'll be sharing with you everything that I learned and we'll be writing a small stored procedure of our own for practice. A stored procedure or SP is basically precompiled SQL logic that lives inside our database. So anytime we write an SQL query, it generally goes through three phases. In the first phase, the database is going to check for syntax errors. Then if it is found alright, it will generate a plan for that query. Finally, it will execute that plan and show us the result. Now, the important part about procedures I need you to know is that this plan is going to get cached and stored inside the database. So in subsequent calls, whenever you use this SP, the database, instead of figuring out everything again, will reuse the same plan. Part of the reason why stored procedures are really fast in terms of execution time. And they're also very versatile. So you can pass parameters inside these procedures and execute your SQL dynamically, and you can also call them through your backend. Stored procedures are like functions in programming, except in this case, they are in SQL. So let us now put this concept into action. We'll be using the famous Chinook database, which belongs to a fictional music store. Now, to install this database on your own computer, you can go to Luis Rocha's GitHub page. This exact link I have got on my screen. And below inside the README file, you'll find the latest scripts to use on your preferred database server. Now that we have got the Chinook database inside our system, let's take a look at a simple use case that we could wrap inside a stored procedure. What are our top 5 biggest vendors? So this looks like a question almost any store would want to know the answer to, right? Maybe we wish to provide them with some kind of loyalty points so that they keep shopping with us. To get the answer to the question, let's take a look at the schema first. We can see that the two most useful tables is the customer table and the invoice table. The customer table has all the information about our customers and it has a primary key of customer ID. But we can see that the table itself does not have any information about sales. That is the job of the invoice table. Each invoice, sort of like a bill, has an invoice ID and it also has a customer ID, which is our foreign key relationship back to the customer. They have also given a total field here, which is the amount the customer must have paid for that particular invoice. So this is what we will add up per customer to get their spendings. Speaking of relationships, we can see that the customer has a one-to-many relation with the invoice table. That is, one customer may have many invoices. So finally, to solve this problem, our plan is going to be something like this. Connect the customer table to invoice using the customer ID. Then add up the total amounts of all invoices per customer. Sort them in descending order. And finally, we'll get the top 5 customers from that list. Now let us start writing our query, shall we? We wish to see customers and their spending. So the very fundamental step we can take right now is to simply list down all the customers that we have and then we will try to build on that result. So let's start writing our first select statement. So if I were to execute just this query, we can see that these are the names of our customers. We can see now that there is no information about their spending in this result set, and we are aware that the spending or the sales information lives inside the invoice table. So our next step is going to be is to join the customer table and the invoice table. So let's do that. And we will also add invoice total in our select statement so that we can see how much the customer spent on that particular invoice. The result of this query when we execute this is going to be the Cartesian product of the customer table and the invoice table, and it is going to be filtered out on the join condition that we have written here. So let's execute this. Now we can see that each customer is attached to all of their invoices, and because we have this join condition, the customers which do not have their customer ID in the invoice table, or in other words, the customers which have not purchased anything, are going to be filtered out. Now if we take a look at the result, that we can see that customer names are repeating. Now if I add an order by, it will be more evident. So if I execute this statement, we can see that each record is an invoice and it has the name of the customer attached to it. So we can see that Aaron has 7 invoices and similarly Alexander has 7 invoices. And what we want is to add up the totals of all these invoices and show one record per customer. To do that, let's also add customer ID into our select statement. So if I execute just this statement, we can see that we are seeing customers and their total amounts. Let's also add an alias to this sum so it's more readable. And when I execute this, we are able to see that the total amount spent by every customer is now visible to us. Finally, since we wanted to see our highest paying customers first, we can order this result by total spending. So let's add an order by here. And if we execute this, these are the highest paying customers of our store. So for example, Helena spent around $49 and Richard has spent $47 so far. We can even go ahead and filter out our top 5. So if I adjust the top 5 statement here, these are our top 5 most prized customers. Top keyword is a bit of TSQL syntax that I used here to make my life easier. But I'll show you how to do this exact thing with the standard fetch and offset in just a minute. First of all, if you made it this far, congratulations. We already have a useful piece of output in our hands, and this looks like something which could be shown inside a report or an internal dashboard. The next logical step we can take right now is to wrap this query up inside a stored procedure so that we can call it whenever we like and we don't have to write the SQL again and again. So if we look here, I have already written the procedure for you and we will go through each line here and understand what exactly it does. So the first statement, create or alter procedure, it is used to create the procedure in our database. I've used create or alter syntax instead of create to make our procedure more idempotent. I'll explain what I mean by that in just a moment. And this USP prefix, it stands for user stored procedure. Your database may already have its own procedures, and this is a convention of defining that this is something we made instead of something that got shipped with the database itself. The next thing we need to take a look at is the begin and end statements. So anything that is in between these two statements is what gets executed each time someone calls a procedure. And finally, the go statement, this is what tells the database that the definition of the procedure is now finished. As promised, I've also used the offset and fetch syntax here. So what this is saying is skip the first 0 rows and fetch the next 5 rows of the result that we have got. So this serves a use case of getting the top 5 most spending customers, right? And usually this is used for pagination. So for example, if you are on page 3 and you are showing 5 records per page, so you are going to skip the first 10 rows, right? And you are going to fetch the next 5. So your offset value is going to be 10, and the next 5 records is going to be your fetch value. I hope that makes sense. So let's go ahead and compile this procedure. So as we can see, it is now compiled, and let's try to execute this, right? We write exec and then followed by the name of the procedure. So if I execute this, we can see that the exact 5 people that showed up in our query are now also visible through our stored procedure: Helena, Richard, Louis, and so on. Now one way we can make this even more useful is to give ourselves the ability to specify how many customers. So right now we always show the top 5 customers by spending. We want to be able to specify exactly top 3, top 5, top 10, anything, right? And the way we can do that is by specifying a parameter for this procedure. So let's do that, and we'll specify the default value as phi itself. So if no one provides a parameter, we can always give the top 5 customers as an output. And later inside our procedure, we will replace the fetch next 5 by top n that we just made here right now. Let's recompile this procedure and go back to our previous screen. Now let's add a parameter inside this execute statement, and we wish to see 10 for this time. Yes, now the top 10 most spending customers are now visible to us. Similarly, we could do top 20, and we are able to see the top 20 of our most spending customers. So this makes our procedure a bit more useful and cater to real life use cases. A few moments before, I mentioned that I would elaborate a bit more on what idempotent means. So let's go back to our procedure here, and if you can see, I have specifically used create or alter syntax here instead of just create. And the reason why I did that is because it could be the case that the procedure already exists inside your database, and if you try to create on top of that, it will throw an error. And this happened to me once, because this one time I was asked to seed a few procedures to our database via ORM's migrations, and I created the migration file for that, got my PR approved, and everything looked fine to me. But when I deployed the code, the app service that we deploy onto, it blew up. And I'll tell you why that happened. It's because the app service is configured on startup to check for any pending DB migrations. So basically the migration file exists inside your source code, but the corresponding entry does not exist in the migration history table. And if that is the case, it is going to go ahead and try to apply that. And that is exactly what happened. But it turned out to be the case that someone had already compiled that SP manually, maybe for testing, and I was not aware of that. So it took me some time to figure out why the app service crashed on startup. And that is why I try to be a little more defensive in my code, and that is what idempotent means. No matter how many times you execute your code, it is going to return the same result. Before I conclude this video, I wish to discuss why stored procedures. What is the case for them? The first one I can tell you is simply performance. We had a utilization report in our system, and it took around 30 seconds to load when you clicked on the page. So when my lead looked at the SQL generated by EF, he was like, no, we can't use this. And he rewrote the whole query by hand. And after a lot of optimization, that report now loads in 5 seconds. Another use case I can tell you is when you have different servers trying to execute a same complex workflow on the database. So instead of trying to duplicate that logic in multiple different code bases and different tech stacks, you could store that inside of a stored procedure. And You can give access to just that procedure to all of these services instead of the underlying tables. Those are all the ones I know, but I want to say that stored procedures are not easy to version and they are definitely not portable. ORMs do a lot of things for us behind the scenes that make our life easier. So it's best to use these only where we see the benefit and not for regular CRUD operations. Thank you for your attention, and I hope I see you again.